All right, so we're going to move on to our second lesson here in Unit 7, Lesson 2. We're on page 66, and we're going to talk about what's something called the hypotenuse leg theorem. And what you're going to see is that this is a special way of showing two triangles are congruent, but it's going to be two right triangles. All right, so we have our four shortcuts that we talked about in our previous lesson that work for all triangles. All right, but this is something that works special, all right, for right triangles. So go ahead and do the opener. Pause the video, do that, flip it back on, and we'll see how you do. All right, so notice what we have here. We have angle, side, angle, right? And we said last time that angle, side, angle is no good, right? So, all right, so these are not congruent, right? And we don't have enough information. And the reason is that this angle right here, and I didn't necessarily explain this in the last lesson, but this is like a hinge, right? So even though this angle is fixed and these two sides are fixed, right, that top angle could hinge, and that's going to create a different, all right, shape. It could also create something with a different size. And so notice we don't even have enough information here to know if it's similar, right? Because we only have the one angle, all right? So that is why angle, side, side doesn't work. Now, okay, let's look at, all right, our notes here. So while angle, side, side is not valid in general, there is a special case for right triangles. Okay, and that is the HL, and that means hypotenuse leg. And so what this is, and I'm just going to draw our picture here. Here's our right angle. So A, B, C, and then D, E, F. So what this says is that the hypotenuses, all right, hypotenusi, I don't know, all right, I don't know the Latin there, all right, I have to talk to Mr. Colsey about that and see. All right, but the hypotenuses, hypotenusi, all right, however you say the plural of hypotenuse, have to be congruent, all right, and then one pair of legs. It doesn't matter which pair of legs, so I'm just going to say that these two. All right, so if we have the hypotenuses congruent, hypotenuse congruent, and we have a pair of legs congruent, we know our two right triangles will also be congruent. All right. Now, what this really has to do with is the Pythagorean theorem. Okay. And what this really says is this, right? And I'm going to say, all right, let's say that this has a length of A right here. Okay. Or let's say this, let's say that this has a length of X. Right? Well, if this is equal, this also has to have a length of X, right? Okay. So if they're congruent, they have to have the same length. Let's say that this has a length of Y. Well, this also has to have the same length of Y, okay, if they are congruent. And I'm just going to say that this side right here is A, and this side is D. Now, if we think about the Pythagorean theorem, then what that says is that A squared plus Y squared has to equal to X squared in the first triangle, right? And in the second triangle, that means that D squared plus Y squared has to equal to X squared. And if I think about this, well, this is equal to this. This is equal to this. Well, the only way for these equations to be equal, right, is if A squared and D squared have to be the same as well, right? Which means that A and D have to be the same. Because notice, if I subtract Y squared from both sides, I get A squared equals X squared minus Y squared. And if I subtract Y squared from both sides here, I get D squared equals X squared minus Y squared. Right? So X squared minus Y squared, X squared minus Y squared. So that means that A squared has to equal to D squared. And that implies that A has to be equal to D. And so really what this is doing then is this is really, because of the Pythagorean theorem and the way it works in a right triangle, hypotenuse leg is really a shortcut for side, side, side. Because if two sides in a right triangle are equal to each other, the third side has to be equal because of our Pythagorean theorem. All right, not that you have to know all that, but I went through that for you just so you have a little deeper understanding of why hypotenuse leg works. So once again, it's only for right triangles. So if we don't see that right angle symbol, right, we can't use hypotenuse leg. We have to use one of our other four shortcuts that we discussed in our prior lesson. So let's look down here at problems 1 and 2 here. All right, so can I use HL? All right, so first thing I'm going to look for is, do I have two right triangles? And the answer is yes. And then my next thing is, okay, are the hypotenuses congruent? And remember, the hypotenuse is always the side opposite the right angle. Okay, so those have the same tick marks. They are equal. So the hypotenuse is good. Now, do I have a pair of the legs are congruent? Well, AB is one leg, and that's congruent to EF, which is the leg over there. So I have both hypotenuse and legs. So the answer is yes. All right, and then that means that triangle. All right, I'm going to go up that leg and down the hypotenuse. So that would be BAC is congruent to triangle EFD, just like that. Okay. All right, notice, can we use HL here? All right. Well, do we have a right angle? Yes. Okay. All right. Now, hypotenuse leg says I have to have the hypotenuse. So I'm going to start with that. Notice, across from the right angle here, we don't know that PQ is equal to RS. So can I use hypotenuse leg? No. Now, that doesn't mean I can't still use one of my other shortcuts, because notice, even though I can't use HL, I do have side, angle, side. Side, angle, side. So just because you can't use HL doesn't mean you may not be able to use another one of your other shortcuts. So notice these triangles are still congruent. So PTQ is congruent to triangle STR, but it's by side, angle, side instead of HL. All right. So sometimes you might be able to use something else even if HL doesn't apply. So I would always look for HL first. If it doesn't work, then does it fall into one of those situations we discussed in our prior lesson? All right, so now you get to finish, all right, the problems here on page 67, and I will see you for our next lesson.